Without further ado, I would like to welcome Amy DeMartine, VP and Research Director for Security and Risk at Forrester, as well as Yaniv Yagolnitzer, VP Product of Reblaze. I'll now hand it over to Amy. Enjoy.
Hi, everybody. My name's Amy DeMartine, and if we go to the next slide, I think we can start right in. So we released a report earlier this year talking about breaches and how they happened. So we do these huge surveys of security professionals. We do other huge surveys, but one of them is on security. And we ask them, was the breach, an internal breach or was it an external breach? And then we do one click down and we say, okay, if it was an external breach, how did it happen? And so multiple responses are accepted. So, if it starts as phishing and then goes to something else, you can select everything that makes sense for those breaches. And this is how the data came out. Number one was web application attack, things like SQL injection or cross-site scripting. And down at number 4 was software vulnerabilities. Now, for the past several years, web applications and software vulnerabilities have kind of vied for number 1 and number 2. But in the year of the pandemic, we actually saw 2 creep in between them. Exploitation of a lost stolen asset, as everyone, all knowledge workers went home, that makes sense. And then computer malware. Malware just exploded last year. What we expect to see this coming year is actually that vulnerabilities and web applications again rise to the top, and that they remain again the biggest weakness that firms have today. So from last year's data, 31% of firms said that they suffered an external attack. And then, like I mentioned, these are how that happened. Now, we did predict that one would go down. We're hoping that computer malware goes down this year because what we're really thinking is that, after last year and all the malware that we suffered, hopefully security controls are better and that malware actually goes down. But we do expect all the other attacks to increase. Once again, vulnerabilities and web application attacks, once again, we think will reign in the top level. Next slide. Okay, so what's complicating this whole, how do you protect applications, whether they be web, they be mobile, they be API? Well, part of it is developers are not slowing down at all. In fact, they continue to get faster. And so this data, once again, one of our big surveys, this is from our developer survey. You can see from 2018 to 2019, we had a huge jump in developers saying that they were able to release applications monthly or even more frequently. And things have slowly increased since. Not a huge jump between 2019 and 2020 or even 2021, but what you do see is slightly growing. So developers are releasing even faster on every, year upon year. They're trying to get their genius out to customers. And of course, security professionals are trying to secure it at the same time. Next slide. Okay, so what else is complicating matters? Well, the next thing is that we've got a lot of different clouds. So developers are putting their code faster out on multiple different clouds. And what we found in our infrastructure survey is that 83% are using 2 or more public cloud providers. So, maybe you look at the public cloud security controls and you think, oh, this is great because they give me all of the control that I need for that specific cloud. But the minute you start thinking about multiple clouds, then you think about multiple security, cloud controls, and then you start thinking, how do I make this consistent around all the clouds? The last number is actually how many have 5 or more, and 23% of respondents said they have 5 or more clouds. So when you think about trying to make the controls consistent using the individual security tools of those cloud providers, it gets very difficult. Next slide. Okay, so next thing we got to talk about is bots. So bots are automated programs, and bots have become really easy to create. There's now bots as a service. You can easily buy bots out on the web. Sneaker bots for as cheap as $25 out on the web. Take it, modify it so that you can go out and buy your favorite sneakers. So bots have become very easy to create, modify, and then launch. So what are they doing? The first thing they're doing is inventory hoarding and checkout abuse. Inventory hoarding is where you hold something in your cart for long periods of time. So for example, hotel rooms, or airlines, or even just from a retailer where you just decide to hold and reserve that, whatever it is, maybe it's shirts or maybe it's groceries, you're going to hold it in reserve so that other people can't get it. The checkout abuse, on the other hand, that's where you actually go and you buy something and then you turn around and you resell it. So, and I'll go through some examples of where we've seen that, most especially during the year of the pandemic of 2020, last year. So the next kind of bot is price scraping and web scraping. Now, scrapers have been around for as long as the internet. So, people want to collect information. Sometimes it's competitive from, so that they can understand how to price their stuff. Sometimes it's investment firms trying to understand what companies are doing. So sometimes it's search engines. Sometimes those are good bots, right? Where you want the search engines to optimize the search on your firm, but at the same time, you don't want to do it at the expense of your good customer traffic. The next thing is counterfeit sales. And we've seen this actually rise in the past year, where you scrape pictures of luxury items and create a website and sell counterfeit items. So you use the luxury item picture to sell counterfeit items. Credential stuffing is where maybe you buy a set of logins and passwords out from the internet, and then a malicious attacker would then use them across every IP address that they possibly can to see if they can get in. Card fraud is things like gift cards, where a malicious attacker will try a series of numbers, either the numbers on a card, number of pins, to try to use it and then get the items for free. DDoS attacks have been around for a long time, and they do seem to be getting bigger and bigger every year. So how do you overload an application with an immense amount of traffic in a short amount of time to try to bring the application down? Ad fraud, there's not a whole lot of regulation between, okay, I want to buy an ad on a certain publication, and then I want to make sure that I'm actually getting out to real users. That space is not very well regulated. And so as a malicious attacker, I can have bots do things like watch ads and then collect the ad revenue. Web recon is where a malicious attacker is trying to go in and actually crack an application open, usually first with credential stuffing. And then once they're in, how do they get into the application, either through a vulnerability or a web application issue, something like SQL injection. How do I break open the application so that I can get into the data underneath? And then the last thing, which is really hard to track, is influence fraud. But some retailers have whole hosts of folks that just deal with influence fraud, because they've got things like bots that try to promote a certain item, or like if you think about Spotify or Pandora, bots that listen to music to try to rise the music's interest. So influence fraud is also rising. Next slide. Let's dive a little bit deeper into checkout abuse and inventory hoarding. So this past year has been very interesting when it comes to checkout abuse and inventory hoarding, especially with things like electronics. So when the PS5 was announced, no one could get them because the bots had already snapped them up. And then, of course, there was this huge resale market. And then we're also starting to see it with graphics cards, as chips become scarcer and people are trying to get at anything, with toys, for example, with any kind of chip in it. we start to see the bots follow. Next slide. So this is actually Google released this. It's overall traffic, the internet traffic that they saw, and it corresponds with the PS5. So, you see where the arrow is on when the PS5 was released, and you see this enormous jump in traffic just to try to get the PS5s. Next slide. Bot attacks actually affect lots of people inside the organization. It's because of all those different use cases that I covered. So for example, security is very interested in credential stuffing, preventing credential stuffing, as well as preventing things like web recon, the ability to crack open an application. Marketing, on the other hand, you just saw that enormous amount of traffic. Marketing, of course, wants to release products and then have good customers visit, customers that they can say, okay, they went through our website in this way. This is how we optimize things. This is how we make it better for our customers. But if you've got bots that are in on your website, marketing can't really understand what is good traffic, true customer traffic, and what is bot traffic. Fraud department, we talked about, especially with influence fraud, maybe liking products more, or credential stuffing, where it actually comes in as a fake user and is even able to check things out. That's where the fraud department is really interested in. E-commerce are the ones that are driving those programs, the release of a new marketing program, a new sales program, especially as we come up to the end of the year. There's lots of different programs that come out from e-commerce where they're trying to attract buyers. And what you want to do is attract good buyers, not necessarily bots. And then the last thing is customer experience. Those professionals are trying to watch out for customers to make sure that they have a good experience. And what we've seen time and time again is bots attack an application and the customer experience is not good. Either the customer cannot get at the products they want, as we saw with PS5 or even with graphics cards, or it's slow, or they end up buying from a reseller, and then the customer experience folks can't go back and say, okay, sneaker, for example, we know you want the next one. So the customer experience people cannot close that loop. Next slide. Earlier this year, Forrester released a new model for how to secure products. We call it the Secure What You Sell model, and we based it on the product marketing model. Now, you're probably thinking, well, for a long time, we've thought of this and mapped it to DevOps, for example. And we tried that and we didn't like the results. What we really wanted was to go even further back to the discover phase, and we wanted to go even farther through a product lifecycle to grow. So we have embraced the product marketing model so that we can go, security hopefully can go to the very beginning of the cycle, even when product management is just thinking about maybe going to launching a product in a new country, for example, or to a new audience, or introducing an entirely new product, and then feedback loops back in grow. Next slide. I want to cover two specific actually phases in the Secure What You Sell lifecycle. So what we have here is sample product management activities, as well as what security should be doing in this phase. So for example, in launch, and this is where a lot of security comes in, especially when security wasn't included from the beginning. We are trying to make sure that applications, as they walk out the door, we all know that applications can never be perfect. So as they walk out the door, what are we doing to secure them? So the product management people, they are launching their dashboard. They are so that they can watch to see how successful the product is. They're trying to make sure that manufacturing, for example, or e-commerce, all of them are enabled, and that sales is enabled to sell the product. But on the security side of the house, we are looking at what kind of security can we launch with this, depending on what it is. Are there specific controls we can do? Things like web application firewalls or bot management or API protections that we can add on. So we really want to protect the value that is being delivered to the customer, whether that be through making sure that we're protecting the customer data or the customer experience. We're also inserting things that we can detect and respond to. So, if there's any kind of malicious activity, how do we know that it's happening? And then how are we able to respond? And any kind of telemetry. That gives us more insight into how customers are using the product. Not only that, but if you start to see weirdness or variations that may cause us to think, okay, we should probably look at this. This might be a problem. Next slide. Okay, this is a little bit of an eye chart, but this shows the adoption of security tools, the ones earlier in the life cycle, as well as the ones in launch. So let me talk to you about launch specifically. For example, web application firewalls are at the very top, broken down by different industries and how they're adopting it. And the lighter green up until the best, which is yellow, that's the highest level of adoption. So when you see this, the darker the color, the less change in adoption, the lighter color, the bigger change in adoption. So you can see for web application firewalls, which have been around for a long time, utilities and telecom are the ones who are changing the most. They are the ones that are adopting it the fastest. Now, if you go down, bot management is about 5 from the bottom? 6 from the bottom, and they are business services and construction are the ones that are really making the leap, followed by financial services. And then API security, which is the 3rd from the bottom. The biggest ones are, once again, utilities and telecom. So as developers create their software in a variety of different ways, and we talked about things like web apps or mobile apps or APIs, security is trying to, once again, protect it, especially in the launch phase. But you can see here, we're seeing APIs really jump in utilities and telecom, and that's why security, of course, is rushing in to protect them. Next slide. Okay, so I want to talk to you about the last phase, which is grow. And something that I think DevSecOps in the past has not covered well, and that is feedback loops. Where are your feedback loops? And there's been a lot of talk in the past few years especially about threat intelligence, and people paying a lot of money for threat intelligence feeds, for example, to understand, generally where are malicious attackers moving so that you can be better protected. But oftentimes what I see is our clients dropping the data that they have that's actually specific to them. They have actually threat intelligence data at their fingertips that they aren't using. So if you think of things like web application firewalls, bot management tools, API protection, they're logging all of the actions of malicious attackers. So you actually know where they're coming exactly in your applications, for example. So you can go back to developers and say, attackers are really focusing on this particular place in the application. So if they're planning on making improvements, removing vulnerabilities, removing web application weaknesses, that's the part of the code they should focus on. And then if attackers think, oh, that's too hard, we're going to go to someplace else, the next release of the product, those feedback loops will tell you if malicious attackers have changed their tactics. And that kind of information is why we really wanted to emphasize the grow phase, which is, okay, now take that information, now that the product has been out in the wilds, take that information and really try to improve the product going forward. And with that, I think I'm handing it over.
So my name is Yaniv. I'm VP product for Reblaze. And I want to talk about Reblaze product, but I want to connect it to what Amy was talking about. So a little bit about Reblaze. We're founded in 2012. We have hundreds of enterprise level customers. We protect lots of websites. We have lots of traffic. So we are actually a cloud native web security platform. We are an enhanced comprehensive solution. We protect various types of vulnerability and security aspects. For example, we provide WAF, bot mitigation, API security, DDoS protection, although all those types of layers of protection that Amy spoke about that are actually increasing, but we are a one-stop shop, if you want to look at it like that, that actually combine all those security features. On top of that, we are built into the cloud and the deployment on all cloud providers. We use AWS, GCP, and Azure. You can find it on the marketplace. And we are cloud agnostic in that phase, meaning that we can be deployed on any cloud. And on top of that, we're not just deployed on any cloud, we are a single tenant. So single tenant means that we are deploying on multiple clouds, multiple regions, but still manage everything from a single management console. The advantage that we brought actually is that you can use Reblaze as a SaaS solution, just like other services. But because we are deployed on the cloud, if you're running on the cloud and we're running on the same region, the same cloud provider, from actually two aspects. First is the latency. The second one, which is important, is cost. We also have the ability to run within your own VPC. So you can take it from the marketplace, deploy it in your own VPC, and then you also gain privacy and, of course, the cost reduced even more. A little bit about the single tenant solution model. So I mentioned we are a SaaS solution where you have a dedicated stack VPC for each customer, but also when it comes to deploying in your own VPC, you have the same stack more or less for your protection. So we actually leverage for whatever the capability of the cloud provider. The global CDN will integrate that within the solution. So we're not just dealing with web security, we also deal with availability and, of course, content delivery as part of the solution. So it's one comprehensive solution, but it's also leveraged from those type of features. Nevertheless, we see all the requests and we leverage that to enhance the security by running some machine learning capabilities. We have real-time monitoring protection, and the data itself, of course, we stored all the data so we can analyze that. The user can actually see all the information and gain the information or gain the knowledge to understand where the application is being attacked, who is the attacker. I would say threat intelligence that Amy spoke about. This is the information that is crucial for understanding the level of risk when it comes to the risk assessment of the application. Just to sum things up, so we are flexible, multi-cloud deployment. We can be deployed in a hybrid solution as well. We have various types of deployment models, lots of security components, all bound together under one comprehensive solution. So that's web application firewall, we have API protection, bot management, DDoS protection, reporting, and all sorts of other goodies, as well as visibility. So with Reblaze, we provide full visibility on the traffic. You can really see everything that comes along in your towards your application. All the information, all the knowledge that we gain, we add an additional layer of knowledge. For example, we understand whether or not a request that comes in is from the Tor network. Maybe it's from an anonymous proxy. We give you all this information, and you are able to of course, define the level of risk for each client. Also, in terms of privacy, each customer gets its own VPC deployment. So we're not using a shared scrubbing centers across. We're using the cloud provider, and we deployed a dedicated stack. As for cost, as I mentioned before, because we are running on the same VPC or on the same cloud provider, the cost, the outgoing traffic is reduced, of course, and you can gain cost, as well as the protection of Reblaze also can reduce the cost because we block those bad traffic that might come, and this traffic never leave the application. A little bit about some case studies. So eBay is one of our customers, and they were facing various types of attack made by bots mainly. The first one was actually scrapping numbers. So prices, as you know, on eBay, they are public, and you can get those prices, but they had very bad issue, protecting those prices. So with Reblaze, it was very straightforward, gaining a protection against bots that actually scrap for those prices. In addition to that, they also suffer from some spam ads. So ads were inserted into eBay, and within those ads, there were some adults links that were not, level with the policy of those applications by eBay. So they ask us, we want to detect whether or not, certain words appear on those ads, and we want to block those ads and stuff like that. People love us. I mean, they're not love the what we represent, and they love, of course, what they're getting. We have great reputation with the customers. We have very low retention rate, and we love to get the feedback. And the product was built from feedbacks that we got from customers. We focus on the customer or the user experience, and we bring that into the technology itself. Now, what I want to do is I want to move on to a demo, demonstrate the product a little bit, dive into some technical aspects, and then we'll go on to questionnaires. So this is the management console. It's a demo environment. The traffic is not real, but it gives you a little bit understanding of what the capabilities of this product. So I talked about visibility, and just like any other product, of course, you can see what's going on in your traffic, how many requests, how many blocks, etc. You can also see how many bot mitigation requests were being done, as well as how many verified human that are verified by Reblaze are seen currently on your application. You can see response, you can see bandwidth, you can also see latency, very important, and you can see your applications. Within each application, you can also see the statistics, for example, where the requests are coming from, who made those requests, what were the targets, the URLs that they were being hit, and also what are the signatures, or what is the vectors that the system had detected for that period of time that we are looking at. So all those information actually derives from the logs. And this is the most, I think, important visibility aspect of Reblaze, is that you see every request that passes through the system, and you can see all the information within the request. So if you click on any of those requests, you can see where the request is coming from, what was the response code, whether or not we know if this is human or not, the origin of this request, and so on. You can also go deeper and understand exactly what these requests are made of. For example, what is the request size, the response size, any headers, cookies. You can also see the origin and how long it took the origin to respond back. In addition to that, you can also see the overall latency that is caused by the WAF. So given that, it gives you a very strong, not just security aspect tool, but also a tool that can be help for the application guys, for the QA, that gives you some information. On top of that, you can, of course, filter the log and analyze for whatever you want to look and focus on. Drilling down to the security aspect of stuff. So Reblaze puts a great deal on filtering or profiling the user, the client that comes in. We estimate the level of risk by running the request against few filters, few lists, and then we determine whether or not the level of risk for that client represent, and then we can, of course, deal with that within the policy itself. So you can create your own list. You can also gain from external lists. For example, if you want to integrate Spam House fraud feed into the system, you can also get that. At the end of the chain, you also have rate limit capabilities. So Reblaze provide simple rate limits, which are look simple, but you can do sophisticated stuff with that. So you can rate limit anything that comes along in the request, and you can, when talking about everything, you can rate limit headers, cookies, argument, whatever comes along in the request, and of course you assign those rate limits various places within the application. As for the rate limit, we also provide an advanced rate limiting capabilities where you can create and use that for your own needs. For each application, you have the ability to assign different rate limiting, different security profiles. For example, for /API, you might want to use a different WAF policy or SQL injection policy. So you can set that up and you can refer to that. In addition to that, you also have the ability to set each one of those security profiles in report mode, meaning that you can set the system in reporting mode and it's not going to block, but perhaps you just want to do it on sensitive places in the application. Maybe it's transactions. You want to make sure that there are no false positives. So you can do that, and you can, of course, refer to that in the logs and determine whether or not there are some false positives that needs to be taken care of before moving into active. Having said that, there are lots of settings that you can set. We're not going to go all over them. We also have another mechanism in the system that actually look on the behavioral of targets and determine, of course, based on some rules that you set, whether or not a target needs to go into a banning list or a simulated banning list. And those targets will be blocked or banned from all the applications. So this is a sort of a threat intelligence that Amy actually spoke about. And you can gain from that, not just understanding what's going on, but you can actually put that into action and ban those bad targets. By the way, you're not obligated to just block IPs. You can block cookies, you can block headers, arguments, whatever you want. A little bit about the profiling. So within the profiling, we mentioned the bot management. So bot management actually can be seen and can be divided into two types of bot management that the Reblaze does. So the first bot management that we're doing is mitigating that on the client side. This is called a passive bot management because we're not blocking those requests, those JavaScript that are called from within the HTML or from the SDK. We also provide SDK for iOS and Android. They are running on the client side. They never meet Reblaze for the first time. The first time they meet Reblaze, they already contain some key that represent that they are validated user. Of course, we validate this content and make sure that they are valid. If they do provide those keys, we will log that in our log as a verified human. The other bot management that we do is an active bot management. So without any need for deploying or adding any calls for JavaScript or SDK implementation in the application, we can set in the policy a rule to deny bot, and we will provide the JavaScript as a response to the request. It's very, very fast to implement that. You can also control for each request whether or not you want to actually have the bot mitigation, or you want it to skip the bot mitigation. And of course, you can add those session profiling that I mentioned with the tags and determine whether or not some certain tags should be skipped from this mechanism. In addition to that, you can also, in rate limit, set up an action to be the bot mitigation. So you have really lots of control over that. Some bot mitigation might interfere with some statistics capabilities that you might use. For example, if you're using Google Analytics, those bot mitigation that you do might interfere with those statistics. But you can, of course, go over this obstacle by launching this bot mitigation not at the first request, or setting that up within, for example, some tag management tool like Google Tag Management. At the end of the process, I mean, you have a system that can provide you lots of capabilities. You can integrate threat intelligence as list that can be import into the system. For example, if you have some internal fraud detection system, or maybe an external fraud detection, and you know already that some IPs represent a very high risk, you can, of course, push those lists into block them before they reach the application. So without further explaining, I think we're okay to move on to the questionnaire.
Sure. So we have gotten a few questions. The first one is for Amy. We are running a multi-cloud on GCP and AWS, and we'll add more public clouds. What should be my considerations when looking for a web security solution?
Yeah, so that means this person falls under the 83% that has more than one cloud. So it can be very difficult if you decide to go and try to manually edit those controls inside of the clouds themselves to make it consistent across cloud deployments. So, you really need to look probably for a cloud agnostic solution that will give you security controls, but without the headaches of, trying to manage each individual cloud.
Thank you. The next one's for Yaniv. To block advanced bots, how important are the ability to set granular rules and have feedback loops that allow to instantaneously see the effect on bot traffic by modifying rules?
Right. So this is very important. The ability to have rules that can be very specific within the application, or very specific against a different service within the application. It gives you control, not just to block all the requests that are coming for one URL or for all the application, but to control exactly within the application what traffic needs to be blocked. For instance, we know about good bots, right? You do want Google crawler, Facebook crawler to come into your site because you're depending on your marketing that they are crawling your website. But still, other bots might need to be getting blocked because there are, scrapers or, some vulnerability scanning and so on.
Wonderful. So, Amy, many security solutions focus on protecting sites and web applications, but they are relatively weak when it comes to API security. In the orgs are planning to adopt side, it seems that organizations aren't currently placing much priority on these aspects either. When do you see this changing?
Well, I would hope that it would have changed years ago, unfortunately, but, especially with open banking, which is going to release a whole host of APIs that are transferring very sensitive data. We've got to get better at this. We've got to get really good at APIs. I think the primary problem is security doesn't know about the APIs. Developers make them, they maybe put API management tools in front and think, oh, we're good to go. But the API management products are really there for things like identity and access management, rate limiting, that kind of thing, and are not as great at the security side. And so first of all, we need to know them where they are. So discovery is key. And then second of all, we need to make sure that they are protected, not just with, whatever API tool that the developers have decided. We do need to lock them down and make sure that they're protected.
Last but not least, Yaniv, today we are using multiple clouds for our apps. One of the difficult issues we are facing is managing the security we use on each of the providers. How does Reblaze handle this problem?
Well, that's a very good question. So Reblaze is a cloud agnostic. It means that we can be deployed on each cloud individually, but still manage everything from a single management console. So you have just one place where you set the policy, you set up the rules, and you don't need to care what cloud provider you are publishing the configuration to. It gives you, great control over multiple deployment, multiple vendors without the headache of managing each one individually, as well as not care about how this provider is working, comparing the policies from one provider to the other.
Thank you. And thank you to Amy and Yaniv for dedicating your time, and to everyone who attended. And if you have any additional questions, please don't hesitate to contact us. And yeah, have a great rest of your day.